So here we are going to discuss about the term entropy generation and some outcomes based on this term. We know that for closed system undergoing an irreversible process, entropy change is equals to S2 minus S1 and it should be greater than the term integration del Q by T. So we can write entropy change is equals to integration del Q by T plus some positive value. This positive value is actually called as entropy generation and it is denoted by Sg. So we can write the mathematical relation S2 minus S1 is equals to integration del Q by T plus Sg. Here del S or S2 minus S1 represents the change in entropy. Integration del Q by T represents the entropy change with heat transfer, and Sg is entropy generation due to the irreversibilities. Therefore, we can say total entropy change is a sum of entropy change due to heat transfer plus entropy change due to the irreversibilities, that is called entropy generation. For reversible process, we know that entropy change is equals to integration del Q by T. So for reversible process, Sg will be equals to 0. So for irreversible process, entropy generation is always a positive value, whereas for reversible process, Sg is equals to 0. But Sg less than 1 is not possible as it will violate second law of thermodynamics. For isolated system, integration del Q by T is equals to 0 as there will be no heat transfer. Therefore, entropy change of isolated system is equals to Sg. So entropy change of isolated system or universe is only possible due to the irreversibilities. Entropy change of universe is equals to Sg, that can be written as del S system plus del S surrounding is equals to Sg. So entropy generation depends on the process. So it is not the property of the system, but entropy is. More the process is irreversible, more will be the entropy generation. If we use the relation del S is equals to del Q by T plus Sg for isolated system, here for reversible process Sg is equals to 0, so del S system plus del S surrounding is equals to 0. For irreversible process, as we know that Sg is positive value, so del S system plus del S surrounding will be greater than 0. By combining these two relations, we can say del S system plus del S surrounding must be greater than equals to 0, or del S of universe must be greater than 0. It is increase in entropy principle, according to which entropy of universe can never decrease. This principle is second law of thermodynamics for system undergoing a process, as we know that Kelvin-Planck statement and Clausius statement are related to the cyclic process only. There are some outcomes based on the term entropy generation. For system undergoing reversible adiabatic process, term del Q by T is equals to 0 and Sg is equals to also 0. So del S is equals to 0 or entropy is constant. That means reversible adiabatic process is an isentropic process. For irreversible adiabatic process, Sg will not equals to 0, but del Q by T is equals to 0. So entropy change will not be equals to 0. So adiabatic process is need not to be isentropic process. It will be isentropic if it is reversible also. In particular case, when integration del Q by T is equals to minus of Sg, del S is equals to 0. Therefore entropy change will be 0 or entropy is constant. So process is isentropic, however it is neither reversible nor adiabatic. For system undergoing a reversible process, entropy generation is 0 and del Q by T may positive, negative or 0. Therefore the entropy of the system undergoing reversible process may increase or decrease or remain constant. Similarly, entropy of system undergoing irreversible process may increase, decrease or remain constant. So if you found this information useful,